No, no, less talent, more elegance. Arms like the swan, not like the hungry velociraptor. Encore. Velourette, what did he say à Bobétaigne en tournant? Non.
Lumi, what in the name of hardened steel is happening here?
Petit jeté, not petit disaster.
Millie, welcome back. I organized a little surprise for you. A celebration, you know, to mark your glorious return to workshop floor.
1, 2, 3, 4. Not one chump fall roll.
And this cacophonal spectacle was the best you could come up with?
It's high art, Millie. Ballet culture. You have been stuck in diagnostics for weeks. I thought you might appreciate something with grace.
Balance, balance. You are not in the jungle. You are on the stage.
I appreciate torque ratios and spindle speeds, not four underdressed dinosaurs flailing to Tchaikovsky.
Arabesque, tail out, closed in. Think swan, not carnivore.
They're not flailing, they are interpreting. It's dance of the Little Swans. And that's Madame Claudia leading them. She trained at the Cretaceous Conservatoire.
This is not a matter how we're at Jurassic Park. Encore une fois.
Oh, she's screaming in French.
Ballet is French, Millie.
Oh, so is defeat, apparently.
You call that échappé? My grandmother's fossil could do better.
Just give it a chance. They worked so hard, especially little Valorette. She only bit her sister once today.
Smile, be not too much. They fear your teeth.
Fine. But if one of them steps on my power cord, I'm going back to maintenance mode.
Hello! A long time no see. Yeah. Well, there is a perfect reason why I have been having this a little bit of a vacation. So I have been, trying to lift up my physical strength and my, my condition. I had recently a heart attack, and this one crippled me a little bit. Well, actually not too much, so I have been training a little bit. I have now been cycling. At the moment the trip is about 15 kilometers. And well, so I'm gaining back myself, so to say. So yeah, well, that's all about that. Just wanted to remind that you should take good care of your health and etc. Okay, okay. So where is it? Well, as you may remember, we had last time a little bit of a disaster. It was this piece that I tried to make, and damn it, it didn't succeed. I have it somewhere, I don't know where I do have it. Okay, anyway, we are going to make a new one today. I'm not the person who gives easily up, so yes, it will be a new one and it will be today. And for those of you who don't know about ballet, well, actually I have been playing with a keyboard some of Tchaikovsky's music, especially the ballet of Lake of Swans, and this one will be the music for today in this episode. So enjoy that, and and also enjoy the machine. And enjoy your life. So let's start. Yes. Okay. I didn't find the old. Wait a minute. There it is. Old and failed workpiece. So, this is something, let me show you. This is something we need to come by, but in correct dimensions. Yeah. Yeah. And the method how I'm doing this to avoid the same mistake I made. So, one thing, I will first level one surface here. It has quite a lot of extra here. So, I will first level it, and after that I will measure, I will turn it around, and then I will level the other side. And then I will measure the width, which should be actually 39 millimeters, and adjust it in a way that it will become straight. I had a problem so that it was wider at the other end and narrower at the other end. That's not good. So now I try to make it so that it's as close as possible straight. After that I can utilize a method which I will present you a little bit later, how to do this the other side. So now I'll mill first both of the side sort of straight, and after that we'll go on trying to make it really parallel. Okay. Now we have here, well, it's actually, well, a few weeks later. But now we are ready to mill this workpiece down to correct dimensions. It is now 0.9 millimeters too thick, and then we have here, it is also a little bit tapered, so that this end here in the back, it is 200ths of a millimeter thinner. So I have put it into the vise so that this end here is 200ths of a millimeters higher. So that now when I mill it, it will become straight. So, and yeah. So we have to peel off 0.9 millimeters out of it. Let's see about the... Yep. And I think we need to set up this correctly. Oh man. Here you are, now. Oh man. So I need to, now it's straight like that. And then I want to touch it a little bit. Let's see. We need to touch the surface now. And I set the power feed on. I will let it warm. It's a little bit slow because it's cold. Okay, now it's touching in the middle. Let's see about, yeah. Okay. And then the feed will be really slow. Speed it up a little bit. Okay. Now it's about 170 revolutions per minute. Well, there you are. I will shut off my voice while doing this and yeah, cutting oil on top here. Not a lot, just something. And I could also spread it so that it's, yeah, okay, it's good. Nice. So now let's start with this one. Yes, well, let's measure this one. The surface finish is excellent. Well, first of all, it was chattering quite a lot at first. Then it broke the insert. I had to change the tool here, the cutting tool. And after that, everything was nice. It made a little bit more sound, but no chatter, which is excellent. And now let's measure this one. It should be quite exactly 39 millimeters on both ends. It's heavy, actually. Yeah, and oily. Oh, yeah, I can hurt myself with this one. Yes, really. Oh, and these chips are nothing short of horrific. So they are short, something like 5 millimeters long, needle sharp and hard. So they penetrate into your feet quite easily. So let's see. 39 millimeters is our goal here. Well, seems like we are a little bit over at this end. And the other end then? It should also be a little bit over. No, it's not. It's exactly, well, it's exactly 39 millimeters. So that's acceptable. Well, actually that dictates how much play I have to add to the dovetails. And now the next step will be to mill these other edges, and this should be 25 millimeters, and now it is a little bit more. It's actually 28. So 3 millimeters away from these surfaces. Shouldn't be too hard. So yeah. So okay, let's see. First of all, this tool ain't the one I'm going to use in this case. This. By the way, for the observant ones of you, this has been a Wollhaupter head. I'm using it as that's really tight. It shouldn't be that tight, but yes. And now let's pick it up from here. Yep, there you are. And change a suitable tool there. That one. I will use that one for finishing. This one is now for my roughing. I know. Okay, and this is actually not the one to use in this case. I have to change this one too. This is a little bit too long. No. It's not too long, it's too short. It's the wrong. Anyway, that's the correct one. No. Why? Man. Am I stupid or what? Well, it's the correct one. So this is wrong. So let's see. Let's put it in place and so there you are. Then let's clean up this one. Oh yeah, and I need to take the burr away from this one. Yeah, but that's. I have here a file like this. It's actually it's from a filing machine. So this one is doesn't have a handle. So this is not to be used in a lathe. Yeah, this is really nice. This file is really good. Okay. So takes the burr quite easily away. Yeah. Here we have one corner which is high. It's no more high. It's still a little bit high. Oh, okay, now it's good. And then that one as well. Well, actually that surface will be milled, so. But now it's very important that these surfaces don't have any high spots, so therefore this doesn't have any now. And this then, this is probably already okay. Yes, it is. So let's see. And then this, we shouldn't have any chips down there. They will spoil your day. And then let's put that side up. Well, I don't hammer this one. I just push it hard down, and there you are. There you are. It's tight. Okay. Oh man. The chips, they are really horrific. Really. I need to change this one because this is contaminated with those chips, and if you wipe your hands with it, yeah, you know you did wipe. So this was 3 millimeters too thick. So I will take, well, how much? 1 millimeter per side first. Yeah. So okay, it turns really slowly now, but let's touch. I'm touching it now. I hope I can hear it. Yes, there it is, I believe. Yeah, okay. 0 the scale, the Z scale is here down. Yes. And then, well, let's see, what's next? The speed first. Oh, yeah, that's not good. I think 500 minimum for this one now. $530. Okay, and then this one, so that, yeah, that's good. And then feed. I think because I'm roughing, I can take something like 70 millimeters per minute. Yes. So I'll have a little bit of a break now. This room is at the moment, well, it's 25 degrees here inside. Well, you might think that it's not a lot, but for a Finnish guy, this is beginning to be a little bit hot for working. So Oh yeah, okay, so I have a little bit of a break and after that we do these sides. Yep. Yes. So now we have to take off 3 millimeters of the thickness of this workpiece. I will do it in two phases. First I take about 1.2 millimeters, probably, yes, 1.2 millimeters from this side. Wait a minute, 1.5 millimeters would be everything. 1.2 millimeters is... Okay, let's take 1.4 millimeters out from this side and also 1.4 millimeters from the other side. So that should leave us 0.2 millimeters to level everything. So, so it means that I will be peeling off 0.1 millimeter from each side with another type of milling equipment, not with this one. This one I will now sort of call rough cut, even though it's only 1.4 millimeters. So now I will start doing that. Now, I have now rough milled this, and it's it's a little bit over 25 millimeters thick, 25.5 minimum, 25 point something at the other. There is a difference between the ends. It's a little bit tapered, but it is because it was really the surface was originally a little bit rough. So it didn't sit straight on here. But now I will first level this side. I'm going to use a different cutter. I'm going to use this one, which is actually, it's a Wollhaupter, like this. Wollhaupter cutting head, which is really rigid, and that I can use to get rid of the roughness of this surface, get it really level, and probably also a good surface quality. After that I turn it around and then I mill it to the dimension. But now let's turn the cutter around. I already have low gear. There I put it on. Oh, this is a little bit tight. It's still tight. Like that. Now a little bit knock here, like that, and it will go off, like that. There you are. And then this one there, let's see if I can get it there easily. Oh, I need to put this a little bit away. Yeah, no, I think I can put it there. Oh, there you are. Huh. Yes. Then we need to have the Z-axis adjusted. Okay, and it's not in the middle. Let's see, I will put it like this, straight. So now I can set the Y to the middle, approximately to the middle, so like that. And now I can check whether this is, well, it's barely going over the edge, so I will make it a little bit wider. So it reaches over the edges. So, oh, now we have plenty. And then the speed for this one. First of all, not 600 revolutions per minute. Now it would be 120, it would be quite nice. And then speed of feed, it should be quite slow, 17 millimeters per minute now. Yeah, okay. Then I scratch the surface. Let's see. And yeah, this small knob here, it's just it locks things. So, okay. I first go near, just visually here. Yeah, now it's very near actually. Just so that it scratches, so I can. Now it's scratching, I believe. Let's see. So, yeah, it's scratching. It's scratching quite a lot, actually. I need to put a little bit off from there. Let's try that. It was very accurate. Yeah, now it's really accurate. So I zero my scale here. Like that. And we don't take, I think this speed is, it should be a little bit more than that. Maybe 150. 200. Yeah, that's probably the correct one. Okay. And what else? What do I forget here? Please tell me. So how much? Let's take only 0.1 millimeter, because I want to be sure when I want to make this surface, the first surface, really level. And when I have done that, then I just switch over to the other side, and then I also make a little bit off from there, and then I measure it, and after that I know how much to take off, and there you are. And this one needs cutting oil. It doesn't work without. I want to switch off before putting my fingers anywhere near here. So yeah. So. And yeah, as you probably have noticed, this is not soft steel. It is Sverker 21, which is quite hard. Even when it's al dente, it's quite hard. But of course, when you harden it, it goes over 60 in hardness scale. So it's really formidable. Really bad news for even for carbide tips. It's really bad news if it's hardened. So now, so yeah, maybe now I start cutting. Okay, now this is quite parallel now. I think it's inside 1/100th of a millimeter from end to end, the thickness. It's very good. So also is the width as well. So, well, next step will be to mill the dovetail here. Well, we have to do it in an official way. So I measure this dovetail here. This has a dovetail. It should match over here. Yeah. And after that, I measure it and I make an initial dovetail there. And after I have done, I measure it as well. And then I know how much to take away from that dovetail so that it's becoming suitable for this one. Well, there is a way how I do this dovetail, and let's see. First I mill the other side, and when the other side is milled, I will turn the workpiece around, and then I mill again the other side, so they become identical. So that way I can ensure that I'm milling it's the same amount of material milled away from both sides. Yeah, so I need to take it away from the vise anyway, so yeah. Okay, but now it's quite hot here, it's almost 30 degrees Celsius, and this is unbearable when it's inside the house. And unfortunately I don't have air conditioning here. I don't need it. This kind of temperature is maybe 1 week a year. Less, mostly less. And that's about it. So for that 1 week I can manage without air conditioning quite well. So yeah, I just have a little bit more breaks. Like now I'm going to have one. So I'll come back after my break, my heat break. Oh. So now I have here a dovetail cutter. My intention now is to cut dovetails. Hence the dovetail cutter. It's a 60 degrees dovetail cutter with something like 12 millimeters outer diameter, etc. But I don't know the exact dimensions. And yeah, but now what I know is that the dovetail is 6 millimeters deep, that direction. And then I don't know about the width, but I have here a measurement system. This here. So these are these two pins which are actually they are just drills, but actually the dimension of these drills is otherwise irrelevant, but they need to be the same, and the size should be suitable so that they engage properly into the dovetail here. And then we have this adjustable parallel which is spreading them and forcing them to the sides. And then I just measure it from here over. And that is telling the width of this dovetail. Similar measurement is done for this dovetail, but this time it will be done from the inside of the pins. So, and then those two measurements should be the same. Yeah. So, and now I should adjust this one so that I can start cutting. And my intention here is that first I cut the other side, and then I turn this workpiece around, and then I cut the other side one more time. So these should become identical. Therefore it's essential that these sides are really straight and parallel with each other. If they are not parallel, the sides will not be identical. If the bottom is a little bit crooked, these sides will not become parallel or identical. But if these conditions are met, then this is a very easy operation. When you have done the first cuts and then you measure this one, then when you compare it to the other one, you know how much make it narrower. And then you just divide that by 2 and make your cut. So advance that much, half of that, and then make the cut, and voila. Actually, this should be ready in just 4 cuts. It should, but yeah, well, things happen. Like we saw the last time, things really happen. So yeah, okay, I'll start doing this, and yeah, and well, I'm going to run this quite slowly, 17 millimeters per minute. There is no rush here, and then the speed will be something like 500 revolutions per minute, the spindle speed. This old machine doesn't like to run fast. It's like me. I cannot run very fast because my coronary arteries are a little bit blocked still. Yes, but now, yeah, but I'll stay alive, at least. So, yeah, what else? Just let's do this. Yeah, okay. Now, let's measure this dovetail the correct way. Well, I have here a document which is really just my notes how to do this. And yes, well, my presentation how I intended to do it the first time was totally wrong. Okay, so let's start with this female. This is a female and this is a male dovetail. So let's start measuring the female. So there are a few things that we need to know in advance before we can start measuring these dovetails. One thing that we need to know in advance is the angle of the dovetail. That is very hard to measure. It's really hard. So we just assume that our dovetail cutter made that angle into here. So yeah, that's one thing. We need to know that it is, in this case, it's 60 degrees. And then we need to know, we need to have 2 pins, which are in this case drills, and we need to know what is the diameter of those pins. That's important, because if we don't know it, we cannot calculate the other dovetail. And yeah, so let's measure it now. Here is a micrometer, and I just measure it. Let's have my 3 pieces on. So the nominal, it's telling here that this should be 3.2 millimeters to drill. Is it really? It's not. This is actually under. It's the stem here is under. It is. Let me see if my micrometer is calibrated correctly. That is also, yes, it is. As you can see, it's really correctly. It's exactly actually. So this is now something else really. these drills, maybe it's drilling that kind of hole, but the diameter of the drill rod is actually 3 point, what is this? So that's actually 3 millimeters. Yes, okay. So it's 3.17 millimeters. This is 3.17 millimeters. Now we have to remember that. And then we should have 2 of those. Let's see if they are identical. Now I became very suspicious with this one. Yeah, this is 1.7. And this is also. Okay. So now we know the diameter of our pins. Next we need to know the depth of this dovetail. How deep is it? The height of the dovetail. And well, when measuring the female, you don't know, you don't need to know that. I think. No. No. You don't need to know it. But you need to know it for the male dovetail. Okay, so in this case, it is 6 millimeters. Okay, so now, you need to know the the diameter of your pins quite accurately actually, and then the height of your dovetail and the angle. Okay. The next step will be to measure, when measuring the female, is to measure the space between the pins. If I put something like this here, like that, can it spread enough? Yes, so if I put my parallel down here, and then I have those drills sticking out there, maybe. There you are. So now this parallel, adjustable parallel, is pushing those, you look here back, pushing those pins against the dovetail sides. And what we need to know is the space inside the pins, the inside space. So we need to measure it here, cross here. And so let's see, how much is that? Well, let's see. That is actually, I try to measure it as near as possible to the, there it is, I believe. No. This went under. Yeah, okay, I need to use that micrometer. Different one. I have 2 here. Yeah, and this is the best way to handle your micrometer when you want to spread it quickly. You could like take here and start wiggling like this, no, don't do that. That will actually destroy your micrometer in no time, actually. Let's see now what this tells us. It's telling us 21, 2, 3, 4 point. Point 13. 24.13. I will. Okay, I don't write this down. I will do the calculations while I'm editing this video. So this is now 22
24.13. Yes, 24.13 is this here. And now, if we want to know, now I can take this away. Now we have the correct measure here. We have measured everything that is needed to be, and what we are calculating is the length of the dovetail here under. This part of the dovetail here. That's what is interesting us. You could try to measure it with your calipers. It doesn't work. I guarantee it doesn't work. So you have to do it like this. But lucky us, the calculations are really simple. I name it T. This one. T, like here. So this is the first one. Now we know. We have a figure here. Then I calculate the T, and that is our reference. The width of this dovetail is that. Okay. So then we take the female. And this one is measured the other way around. So we put our pins here like this, and since we are now measuring actually the outside of the pins, not the inside but the outside, I used to have a thing like this there. You don't need it. You just measure it from the outside. The micrometer is actually pushing the pins into the dovetails. Just make sure that they are clean. And sometimes you really need to have it. Let's see now. Yeah, here, there you go. There you go. That was easy. So now, male dovetail is measured outside the pins, and female is measured inside the pins. Oh, go figure. And this one is now 30. 1, 2, 3, 34, 33 point 82. 33.82 is that measure. Okay, and now I will put it into my formula and the other formula, and then I will calculate these. And sorry, I don't. I put the calculation somewhere here, as you can see, and well, the formulas are like that. And now I don't calculate it here, but now we can see whether this dovetail would work or not. I think it's a little bit tight. It feels tight here, but you never know. No. Yeah, it feels a little bit tight. This might be good when you debore it, really. So, let's see. This was also funny because this dovetail, the deboring can be done with a cloth. It's so minuscule, so thin. This burr, and it's gone. No, it's not. There we have a. Yes, I can feel it. Let's see if I can file it away. We can try this out. Huh. There is something. This is, by the way, a special file. Okay, that pull is easy enough. A special file, this is for a filing machine, and therefore, if you can see, it has no handles, but it has two identical ends. It's a really good quality file, so I have been using it for things like this. I just try to get rid of, if there are some burrs, they should be away now. Let's see whether this fits. Let's see if my calculation is correct. I don't know. Let's see. Okay, it's... No. And you don't do this with mild steel. This is tool steel and it's not very... It doesn't gull easily. It will gull, but not easily. It's almost there. Let's see what our calculations tell us. Yeah, it's... oh yeah, okay. I think I need to... it might benefit from some emery paper. So let's go now and let's do the calculations here and the conclusion, which I will tell you after that one. There are also particularly one video in the internet, in the YouTube, is one that is a really good one, and it's filmed by a person called Mr. Pete. He's an American machinist and has been teaching people in the school, really, and seems like he knows what he's talking about. So yeah, so now we start cutting, because well, I already cut this, but now we start in the video, we start cutting. So let's go on. So now it's time for the measurements. So I need a pen. I noticed that I don't have one here. So first I measure this one. I choose another kind of drills here. They were originally almost 5 millimeters and they were too thick. So now these are 3.2 millimeters. Yep. And now I will measure the pins here, the outside of the pins here. Let's see whether I get it right. This should be easy to measure. Okay, there you are. It's a little bit flexing, so you should be really careful with this one. Yeah, I can see it flexing. I have to choose another kind of parallels here, I believe. This is too big. Okay. Now I invented it. I use two. So this way around, or maybe this way around. It should actually, if I put this now here, this is a little bit finicky. I would say not the easiest measurement I have ever done. But now, yeah, okay. Now it supports the pins all the way. I'll show you, maybe you see it. And now I can squeeze it and then measure it. Yeah, it's rock solid now. Yep, okay. Now it's measurable. So let's see, this side first. Yeah. So the result is Mm-hmm. $13.45. Okay, now what I will do, I will actually turn this around and measure the other side. So then I know, I can see whether it is the same the both ways. It should be 13.45. Now it's a very good chance to forget this 13.45 if I don't write it down somewhere. So I'll write it there. 13.45. Yeah, there it is. Now let's see that one again. Okay, it goes both ways. I can put the support piece either side. So let's see which side. That side. Rock solid. So 13.45 was the previous. Now let's measure this one. Didn't lock it, so it moved. It's quite important when you are measuring strange surfaces. So this is a little bit smaller, 13.44. So, okay, 43 actually. So I'll assume that it is that 45. No, yes. So I can make this smaller, a little bit brighter, and then I can mill it down. And now, the next patient will be. Now we know how this is. Perkele. One thing about this measurement method is that you don't get easily these out. It's hard to get them in and even harder to get them out. Okay, now it released itself. This will be needed. This not, but I will keep it here. And those, yeah. And now, since we are measuring the inside of the pins, I have this machinist score, whatever, machinist score, is it? No. Let's see if I can put it this way, so it supports itself. There. No, I don't see anything. And now you have to be really clean with these when you put them here, so that you don't put any chips there, because these will make your things go haywire. Yes. Now the fit is exactly what I want it to be. Well, my calculation, measuring, etc., that was wrong. I need to figure out what I did wrong, and then I will do a post-processing recording of that. But anyway, now the fit is such that there's no. So I need to. Well, when I deburr these, and maybe grind or whatever I do on top of this away a little bit from here. So like 5 microns or something like that. So sandpaper or something. So that after that it will be a sliding fit, but just bare sliding. So then it's really good. So and when it is tightened, it tightens immediately, so to say. Okay. But well, this is already quite a long video, and you are probably fed up with Tchaikovsky, I believe. Hopefully not, actually. It's very beautiful music, and yeah, okay. And if you wish me to make these videos in another way, I can do that, of course. For example, I'm not sure of like milling a workpiece to dimensions is worth well, a long time of video, but there was this music. It actually dictated the length of the video. So now I will choose shorter passages from that music for that one, so maybe. Okay, so yeah, this was a successful thing, and now we can go on with this one because we have a proper dovetail here, and it's really good match. So it should be strong, and if you wonder why I was taking so thin cuts out of this, so this is tool steel, and yeah, and it's tough. It's not mine steel. So yeah, it's tool steel. That's the reason why. I don't want to break my things here. Okay, so till the next time then. Yeah, till next time. Bye bye.